now we are going to discuss on how to find inverse of a matrix. Okay, so we will discuss these three methods. Okay, so the first one is Adjoint method. Okay, second one is called Deduction method. And lastly, elementary row operations. Okay, so now let's discuss the first method, Adjoint method. So for this Adjoint method, we do have formula for inverse matrix. So the formula is A inverse is equal to 1 over determinant multiplied by adjoint of A, where adjoint is simply cofactor matrix transpose. Okay, so in order to discuss this method, so we will see one example here. Okay, so we are given this matrix A, so find the determinant of matrix A. Okay, so in order to solve the first part, okay, let's recall the formula of determinant. So determinant of A is equal to sum of Aij multiplied by Cij. So we can choose to expand any row or any column. Okay, so in this solution, so we will expand the first row here. So this is the first row. Okay, whereby 2 is the element in the first row, first column, and here 2 is the element in the first row and second column, and 3 here is the element in the first row, third column. So by expanding first row, so the formula will be A11 C11 plus A12 C12 and plus A13 C13. And because we know that Cij is equal to -1 to the power of I plus j times mij, so we know that C11 is simply positive of M11, C12 is negative of M12, and C13 is positive of M13. Okay, and then we replace A11 with this element 2, okay, because A11 is the element in the first row, first column, and then minor M11 is basically the determinant of the matrix remains after we close the first row and first column. So by closing the first row and first column, so we can see the elements left are 5 4 1 4, and we plug in here. So and we bring down A12, which is the element in the first row and second column. Okay, so we write down 2 here, and then if we close the first row and second column, so we can see the elements left are 1 4 3 4. We bring down all the elements and we write down the A13. So A13 is the element in the first row and third column. And then how to find M13, so we just close the first row and third column, so we can see clearly the elements remain 1 5 3 1. Then we bring down, so we just find all the determinants of these 2 by 2 matrices, and we will get the answer to be 6. Okay, so part A done. Okay, now coming to the second part, find the minor, cofactor and adjoint matrix of A. So because we know again minor, so minor elements are the determinants of the matrix remain after we close the respective row and column. So we can see that, okay, so since we already have all the minor in the first row, okay, so these 3, so we can simply bring down all the values here. Okay, and we just close the respective row and column. Okay, for matrix A, so we will see the minor elements are as listed down here. Okay, and then we just solve all the determinants and we will get this answer. Okay, and then how to get cofactor? Okay, because we know, okay, again cofactor is simply the plus minus plus of minus, right? So this is the formula just now. Okay, so we just put all the plus minus plus symbols and we bring down all the elements in this minor matrix. Okay, so we will get this answer. So that is cofactor matrix. Okay, and then how to find adjoint? Okay, so adjoint is cofactor transpose. So okay, we bring down all the elements in the cofactor and we put these for transpose. So again, transpose is interchanging the row to be column, or we change the column to be the row. So we can see that, okay, so this first row 16 8 -4, so this has become the first column, and the second row here has become the second column, and third row here has become third column. So that is the answer for adjoint matrix. Okay, then for the next question C, we are given this and we need to prove the formula of A inverse. So we are given A multiplied by adjoint of A is equal to determinant of A times I. Okay, so because we don't have any A inverse, so the idea is if we don't have one, then we can create one. So we multiply both sides by A inverse. So we will have A inverse multiplied by A times adjoint of A equals to A inverse times determinant of A times I. Okay, then we will have A inverse times A is I, and then adjoint of A we bring down, and then because determinant is simply a scalar, so we can put it here, and we just perform the multiplication between this A inverse and I, so it will be simplified to be A inverse. Okay, then again, any matrix multiplied by I is the matrix, right? So because adjoint of A is a matrix, so multiplied by I we will get simply adjoint of A. And then A inverse here we bring down, so then we just write down A inverse as a subject. So we bring the determinant of A to the other side, so we will have A inverse equal to 1 over determinant times adjoint of A. So that is how to show, okay, the expression. Okay, then hence the question says find A inverse. So because you already have the determinant and also the adjoint, which is cofactor transpose, so we bring down all the elements. Okay, so we just get the answer, and we can also check this answer using calculator. Okay, now how to find inverse matrix using second method. Okay, so this second method is called deduction method. Okay, so ABK equals to KI. So how to use this method? Okay, now let's see an example here. So we are given two matrices A and B. Show that AB equals to KI. So we need to show that the product of A and B will give us a scalar multiplication of K with identity matrix, where K is a constant and I is identity matrix. Okay, so we have this first part, which is the proving question, and then find the value of K, second part of the question, and hence obtain A inverse. Okay, so please be alert here, we do have hence word, so there is something that we have to do. Okay, so now let's perform the matrix multiplication. Okay, so if you recall back the concept of matrix multiplication, so it's always row by column. So row of the first matrix multiplied by column of the second matrix. Okay, so if we see here, so we will have all the products here. Okay, we need to show each of this. Okay, so we have -2 times -1 plus 0 times -1 plus 0 times -1, and then here for the second column we have -2 times 0 plus 0 times 1 over 5 plus 0 times -2 over 5. Okay, and then we have -2 times 0 plus 0 times -1 over 5 plus 0 times -3 over 5. Okay, so that is for the first row, and we do the same for second and third, so we will get this answer. Okay, so it's actually the matrix of 2 0 0 0 2 0 and 0 0 2, and we can take the 2 out, factorize the 2, and we will have 2 multiplied by this identity matrix. So now we have shown that AB is equal to 2i. Okay, so now the second part of the question, find the value of K. So because we have shown AB is equal to 2i and we compare with AB equals to KI, so we may conclude that the value of K is 2. Okay, so now how to find A inverse? Alright, so by using deduction method, okay, so originally we have AB equals to 2i, so we bring it down. Okay, now because the question says find A inverse, so we cannot see any A inverse here. Okay, so the concept is, okay, if we don't have one, okay, if we don't have one, we create one. So let's see here, in this equation, okay, we do have AB equals to 2i, so we don't have any A inverse. So in order to create one, we just multiply both sides by A inverse. But okay, we need to bear in mind that matrix multiplication is not commutative, so we know AB is not equal to BA. So we have to be very careful when we multiply both sides by A inverse. So we need to see the position. So because A here is at the front, so we are going to put A inverse also at the front. So we cannot put behind here. Okay, so we have to multiply A inverse at the front. So if you do the same, okay, if you do for the left hand side, we must do the same for the right hand side. We put the A inverse at the front. So A inverse times AB, and then equals to A inverse times 2I. And because 2 is simply a scalar, okay, so we can bring the 2, okay, to the front here. So A inverse multiplied by A will be I, and then B here we bring down. Okay, then 2 A inverse times I. So again, we use this property. Any matrix multiplied by identity will be the matrix. Okay, so now we have A inverse times I, which is A inverse. Okay, and IB is simply B, so we write down A inverse as a subject, so we know that A inverse is equal to 1 over 2B. So this is what it meant by hence. Hence means we need to use our previous result. So our previous result is this, so we have to use this. So we don't have to find inverse using adjoint method anymore, because we already have the matrix B here. Okay, whereby by deduction just now we have shown that A inverse is simply half of matrix B. So we bring down the values of elements in the matrix B, okay, and we can obtain the A inverse by finding this scalar multiplication. So we multiply 1 over 2 with each and every element in matrix B, so we can obtain the A inverse.